Hi, this is Mrs. Vrobel. This is Chapter 11, Stoichiometry Part 1. Some students kind of have mixed feelings about this chapter. They're like, what is stoichiometry? Well, we're going to bring our good friend the mole back, and he's going to help us to understand the following. So, we're going to look at what are the relationships that are found in a chemical equation, and it has to be balanced, of course. And then we're going to look at what we call mole ratios, and we're going to use those mole ratios to help us figure some things out. Okay, so stoichiometry. I know it's a very big sounding word, but all it is the relationship between reactants and products. And you've been doing that already with some of your equations. This is where it gets to be a little bit of a challenge. We're looking at calculations. We want to know how much do we have of a product or how much do we start with in a reactant. So think about it this way. If you were a pharmacist and you were trying to make a drug, you would want to know how much product, how much medicine are you going to make based on your starting materials. And chemists all around the world do that all the time. So they're essentially predicting the amount of products. So if you were baking cookies, you would want to know how many dozen cookies are you going to get out of the starting materials with butter, sugar, eggs, flour. For chemistry, we could say if we had copper and we wanted to use silver nitrate and we wanted to generate some silver, let's look at the following equation. Once again, notice that with these reactants and products, we have to say what exactly is the state that it's at. So here we have solid, we have water-based silver nitrate, we have aqueous copper nitrate, and then we have solid silver. We can't just go by the components of the reaction. We have to look at what are the coefficients. So once again, we have to look at the coefficients and make sure that the amount of reactants equals the amount of products. So here we had to add the coefficients of 2 in front of silver nitrate. So hopefully from your naming, you remember what these compound names are. And we had to put a 2 in front of silver to make sure that the amount of reactant atoms equals the amount of product atoms. Now, they throw in this caveat here. If you had 1 mole of copper, how many moles of silver would you produce? So now we're bringing in the mole. So we're going to assume because there's a 2 in front of silver nitrate, we're looking at 2 moles of silver. Now, if, I'm sorry, I said silver nitrate, didn't I? I meant just silver metal. Now they ask you if you had 1 mole of copper. Remember, there's an understood 1 in front of this copper. So there's an understood 1 right there. And they want to know how much silver would you produce? Now this is where we want to use mole ratio to help us figure it out. Now notice that there is a 2 in front of the silver, okay? We're gonna multiply it by the molar mass of silver, and when we do that, that gives us the mass of silver. So here we took the moles of silver metal and we just multiply it by the molar mass of silver atoms, and we got 215.74 grams. Okay, so here's another situation where we want to predict our product. So they tell us that we have 127 grams of copper, and if we added it to silver nitrate, they want to know how much silver could we produce from that. So the first thing that we have to do is we can't compare apples to oranges. We have to take the copper and first convert it from mass of copper into moles of copper. So when we do that, notice that we're dividing it by the molar mass of copper. And molar mass of copper is 63.54. So when we do that, we are left with moles because grams cancel out, and that gives us moles of copper. Now we want to convert copper to silver, so this is where we need to look at the moles of silver versus the moles of copper. This is what we call mole ratio. So mole ratio is just um, two molar amounts of different substances. And notice that we're using the coefficients that were in front of each in the chemical reaction. That is really important. So once we take the moles of copper, notice that moles of copper cancel out and we're left with moles of silver. So we essentially doubled the amount of copper, and that became the moles of silver. Now we're not done because we want to know the mass of silver. So notice that we take the moles of silver that we got from the last equation, and all we do is we multiply it by the molar mass of silver, and that's 107.87 grams. So that our final product mass is 431.21 grams. So please remember, with mole ratio, we're talking about taking the coefficients in front of each and just creating a fraction. That's all we're doing. Okay, so in summary, you want to have a balanced equation. You cannot do this type of prediction if it was not balanced. And please remember that whatever amount of product we got, that was due to the amount of reactant. So we have to make sure that we have the same number of atoms for each side of the equation. And the mole ratio, all it is a fraction, and we use the coefficients that are found in a balanced chemical reaction to give us mole ratio.